Namaste and welcome. In today's session, I will be working out some more questions based on properties of determinants. As I told you earlier, this particular concept is very important and you will find one question either for 4 marks or for 6 marks in the board examination. Here we go. The first question goes like this. If x, y and z are all different and the determinant x square 1 plus x cube, y square 1 plus y cube, z square 1 plus z cube equal to 0, then show that x, y, z equal to minus 1. This question is actually taken from the NCERT textbook, but also in 2008 and in 2011, the same question was asked in the board examination. Now let's do this. Solution. What is given to you actually? X, y, z, x square, y square, z square, x cube, 1 plus x cube, one plus y cube, 1 plus z cube equal to 0. Now, if you see the third column, every element over there is sum of two elements. As per one of the properties of the determinants, this determinant can be written as sum of two determinants. Like this implies x, y, z, x square, y square, z square, 1, 1, 1 plus x, y, z, x square, y square, z square, x cube, y cube, z cube equal to 0. Now what I am going to do? I am going to take x from R1, y from R2 and z from R3 in the second determinant. So let me name this as 1 plus 2. Okay. Now taking out x from R1, y from R2 and z from R3 into, in this second determinant, I am going to take out x from R1, y from R2 and z from R3. So what will I be getting? This implies determinant x, y, z, x square, y square, z square, 1, 1, 1. This is my first determinant plus, since I am taking out x, y, z from the second determinant, I will be left with the determinant 1 x, x square, 1 y, y square, 1 z, z square equal to 0. Okay. Now, this is my second determinant actually. Now, here, if you compare 1 and 2, all the elements are same. The only thing is that 1, 1, 1 here is the first column, but whereas it is in the third column. Same way x, y, z and x, y, only the columns have been interchanged. So what I am going to do over here, and already I told you, in a determinant, if any two rows or any two columns are interchanged once, the value of the determinant will become negative. If you are going to make one more change that way in column or row, then it will become positive. That's what I am going to do here in determinant 1. What I am going to do here is, I am going to interchange C2 and C3 in 1. What will happen? Determinant x, negative of the determinant x, y, z. Because only one shift I am doing. Then 1, 1, 1 x square, y square, z square plus x, y, z 1, 1, 1 x, y, z x square, y square, z square equal to 0. Now I am going to shift 1 and 2, that is C1 and C2. So this is your 1 plus this is your 2. Now C1 and C2 I am going to interchange in 1. So one more negative sign. So minus into minus positive. I will be left with 1, 1, 1, x, y, z, x square, y square, z square plus x, y, z into 1, 1, 1, x, y, z, x square, y square, z square equal to 0. This is what I am getting. Now, these two determinants are one and the same. So let me take out. The inside I will be having 1 plus x, y, z. So, determinant 1, 1, 1, x, y, z, x square, y square, z square into 1 plus x, y, z equal to 0. Here in this determinant, I am going to write R2 as R2 minus R1 and R3 as R3 minus R1. I am going to make these two changes here. And let me write and. So what will happen here? First row will remain the same. Second row, 1 minus 1, 0. Y minus x. Here y square minus x square. Same way, 1 minus 1, 0. Z minus x. Z square minus x square into 1 plus xyz equal to 0. Now, I can take out y minus x from R2 and z minus x from R3. Then what will I be getting? Taking out y minus x from R2 and z minus x from R3, we get y minus x into z minus x into determinant. Now, first row R1 will remain the same. 1 x square. Here 0. I am taking out y minus x. So I have here 1. Y square minus x square is y minus x into y plus x. Anyway, y minus x is outside. So I will be having only y plus x. Same way here 0. Z minus x already I have taken it out. So I will be having only 1. Here it is going to be z plus x into 1 plus x, y, z equal to 0. So this is what I am having. This can be written as, so I am writing this as 1 plus x, y, z into y minus x into z minus x. Y minus x into z minus x. Now the determinant 1, 0, 0, x, 1, 1, x, 1, 1, x square, y plus x, z plus x equal to 0. Expanding through C1, we get 1 plus xyz into y minus x into z minus x into, see here 1 into product of 1 and this z plus x minus product of 1 into y plus x. So that will be z plus x minus of y plus x equal to 0. Now if I remove the bracket over there, I will be getting 1 plus xyz into y minus x into z minus x into, here if I open the bracket, x and minus x will get cancelled. I will be left with only z minus y. z minus y equal to 0. Now, 1 plus xyz into x minus y, I am taking out one minus sign. Here one minus sign I am taking out. So minus into minus plus. So x minus y, y minus z into z minus x equal to 0. But what is given here? X, y and z are all different. That means x is not equal to y and not equal to z. So, if I equate this to 0, x and y will be equal. So, that is not possible. Here, y will not be equal to z as per the given condition. Same is the case with z minus x equal to 0 implies z equal to x. Even that is not possible. So, you should write, since x is not equal to y, not equal to z given, they are all different. The only possibility is given x minus y cannot be equal to 0, y minus z cannot be equal to 0 and z minus x cannot be equal to 0. The only possibility is 1 plus xyz should be equal to 0. So, implies 1 plus xyz equal to 0, which implies xyz equal to minus 1. That is what you need to prove. Okay, hence proved. Finally, you have to write the answer again. We have proved that xyz equal to minus 1. That will be your final answer. Now, the same question was asked in 2011 in one of the sets. Instead of xyz, everywhere it was in terms of a, b and c. Instead of asking you to prove xyz equal to minus 1 in the sum, there it was asked as 1 plus abc equal to 0. See, that's what we are getting here also. 1 plus xyz. Instead, since everything is in terms of abc, they asked to prove 1 plus abc equal to 0. But actually, all the steps are similar. Same thing. It is the same question. Only thing is, instead of xyz, it is changed as abc. So, the same method, the same step should be written by you to answer the questions of that time. Now, let's move on to question number 2. Now, here you need to prove that determinant x square 1 plus px cube, y square 1 plus py cube, z square 1 plus pz cube is equal to 1 plus pxyz into x minus y into y minus z into z minus x. This question is taken from the NCERT textbook. Also in 2010, the same question was asked in the board examination. Actually speaking, this particular sum is similar to the question number 1, what we did in today's class. Let's do it now. Solution. Take LHS. X, y, z, x square, y square, z square, 1 plus px cube, 1 plus py cube, 1 plus pz cube. Now, in column 3, every element is sum of two elements. So, this particular determinant can be written as sum of two determinants as per the one of the properties of the determinants. Okay. Which is equal to x, y, z, x square, y square, z square, 1, 1, 1 plus x, y, z, x square, y square, z square, then px cube, py cube, pz cube. Okay, let me name this as 1 and this determinant as 2. I am going to take out x from the first row, y from the second row and z from the third row in determinant 2. So what will happen? Let me write that now. Taking out x from R1, y from R2 and z from R3 into we get LHS is equal to determinant x, y, z, x square, y square, z square, 1, 1, 1 plus x, y, z into 1, 1, 1 x, y, z px square, py square, pz square. So this is the first one, this is the second one. Okay, now what I am going to do, I am going to take out p from C3 because p is common there in C3. I am going to take it out. So that will give me, taking out p from C3, we get LHS is equal to determinant x, y, z, x square, y square, z square, 1, 1, 1, first determinant, plus, already one x, y, z is there, now I am taking out p. So I will be getting p, x, y, z into the determinant 1, 1, 1, x, y, z, x square, y square, z square. 1, 1, 1, x, y, z, x square, y square, z square. This is the second determinant. Actually, the entire thing is second one. Now, if I compare 1 and 2, what will happen? All the elements are same. Only thing is the columns have been interchanged. Like the previous question, what I am going to do? I am going to shift C2 and C3 and then C1 and C2. I will be getting, so let me write that now. C3, C2 and C3 in 1. I get LHS is equal to negative of x, y, z, 1, 1, 1, x square, y square, z square plus p, x, y, z into 1, 1, 1, x, y, z, x square, y square, z square. Okay. Now, I am going to one more shift I am going to make. So that will be C1 and C2 in 1. So as usual, this is 1. This entire thing is your 2. Now I will be getting negative signs and minus into minus will become positive. I will be getting this as determinant 1, 1, 1 x, y, z, x square, y square, z square plus p, x, y, z into 1, 1, 1 x, y, z, x square, y square, z square. That means both the determinants are one and the same. That I am going to take it out as common. So I will be getting it as 1 plus p, x, y, z. This is LHS actually. Into determinant 1, 1, 1 x, y, z, x square, y square, z square. Now, it is easy for me to make these two entries 0 like the previous sum. So, question number 1. So, what I am going to do over here, I am going to write R2 as R2 minus R1 and R3 as R3 minus R1. So, what will I be getting? 1 plus p, x, y, z into first row will remain the same. There won't be any change. Second row will become 0, y minus x, y square minus x square. Then R3 minus R1, 0, z minus x, z square minus x square. Now, I am going to take out y minus x from R2 and z minus x from R3. Taking out y minus x from R2 and z minus x from R3, we get LHS is equal to 1 plus PXYZ into Y minus X into Z minus X. Okay, I will be left with the determinant. First row will remain the same. Second row 0. Already Y minus X outside. So I will be having here 1. But Y square minus X square is Y minus X into Y plus X. Y minus X is here. So naturally I will be having here Y plus X. Same is the case with the third row. 0. Z minus X is here already. So 1. I will be having Z plus X. Now I am going to expand this determinant using C1. I will be getting expanding through C1, we get LHS is equal to 1 plus PXYZ into Y minus X, Z minus X. Y minus X into Z minus X. Then, when I expand, leaving the first row and first column, it is the product of 1 and Z plus X minus product of 1 and Y plus X. So, that will give me Z plus X minus Y minus X. So, this is 1 plus PXYZ into Y minus X into Z minus X. Here plus X and minus X will get cancelled, left with Z minus Y. Now, if you see, if I can take out minus sign, it will become X minus Y. I can take out one minus sign from here, it will become Y minus Z. So, minus into minus plus. I will be getting, this is nothing but 1 plus PXYZ into X minus Y. Since I have taken out one minus sign from there, this will become Y minus Z into Z minus X, which is equal to RHS. So, you got your LHS is equal to RHS. That is LHS equal to RHS. What is LHS? Write this determinant is equal to this, already approved. Now that is already part of the answer. That is, you answered the question up to this point. You need to conclude your answer. Therefore, answer is, this is equal to determinant. This is equal to 1 plus PXYZ into X minus Y into Y minus Z into Z minus X. Hence proved. That is how you will be concluding your answer. Now, we will move on to question number 3. Here, using the properties of the determinants, you need to show that the value of this determinant is equal to 1. In 2009, this particular question was asked in the board examination. Let's do it now. Solution. LHS determinant 1, 2, 3, 1 plus P, 3 plus 2P, 6 plus 3P, 1 plus P plus Q, 1 plus 3P plus 2Q, 1 plus 6P plus 3Q. This is what you are having. Here what I am going to do is, I am going to write C2 as C2 minus P times C1 and C3 as C3 minus Q times C1. Now what will happen? LHS will be, see here, first column will remain the same. Second column, C2 is 1 plus P minus P times C1 is P. So I will be having 1 plus P minus P. Here it will be 3 plus 2P minus P times C1. So minus 2P. Here it will be 6 plus 3P minus 3P. What will happen to third column? It is C3 minus Q times C1. So, 1 plus P plus Q minus Q. Then 1 plus 3P plus 2Q minus Q times 2, that is 2Q. Then 1 plus 6P plus 3Q minus 3Q. This is what I am getting. Now this is nothing but, that is LHS equal to, plus P and minus P will get cancelled, 2P minus 2P will get cancelled, 3P minus 3P will get cancelled. Same way, Q minus Q will get cancelled, 2Q minus 2Q will get cancelled, as well as 3Q minus 3Q will get cancelled. You will be left with determinant 1, 2, 3. Here I will have 1, 3, 6. 1, 3, 6. Here I will be having 1 plus P, 1 plus 3P, 1 plus P, 1 plus 3P, then 1 plus 6P. Now I need to see what is to be done over here. So it is very simple. I am having here P, here I am having only 1. 3P I am having 3. 6P I am having 6. So I can write C3 as C3 minus P times C2. P times C2. Now what will happen to LHS? LHS will be, first column will remain the same. Second column also there won't be any change. Third column it will be 1 plus P minus P times C2. That will be minus P. Here 1 plus 3P minus 3P. Then 1 plus 6P minus 6P. So P and minus P will get cancelled. 3P minus 3P will get cancelled. 6P minus 6P will get cancelled. You will be left with 1, 2, 3, 1, 3, 6. Here I will be having 1, then 1, 1, 1. That's all I will be having here. Now, it is easy for me to make 2 entries 0. So, what I am going to do now is, I am going to write C2 as, see here, C2 I can write it as C2 minus C1. C2 minus C1 and C3 as C3 minus C1. I will be getting LHS determinant equal to, first column will remain the same. Second column, 1 minus 1 is 0, 3 minus 2 is 1, 6 minus 3 is 3. Then coming to C3, it is C3 minus C1. So 1 minus 1, 0, 1 minus 2, minus 1, 1 minus 3, minus 2. This is what I am getting. Now I can easily expand this using first row. So expanding through R1, we get, this is nothing but 1 into, so leaving the first row and the first column, 1 into minus 2 is minus 2, then minus of 3 into minus 1, that will become plus 3. So, plus 3 minus 2 is 1, which is equal to your RHS. Therefore, LHS equal to RHS. Then you should write this determinant is equal to 1. With that, the question will be over. You need to write your answer. Hence, the value of the determinant 1, 2, 3, 1 plus P, all these things you should write, which is equal to 1. Hence, proved. That will be your concluding answer. Okay. Now we will pass on to question number 4. This question is rather a very easy question. You need to write the value of the determinant A minus B, B minus C, C minus A, B minus C, C minus A, A minus B, C minus A, A minus B, B minus C. This question is there in the NCERT textbook. Also, in 2009 and in 2016, the same question was asked in the board examination. Let's do it now. Solution. I can write this determinant as A minus B, B minus C, C minus A, B minus C, C minus A minus B, C minus A minus B, B minus C. So what I am going to do here is, I am going to write R1 as R1 plus R2 plus R3. Now I will be getting A minus B plus B minus C plus C minus A. Second entry will be B minus C plus C minus A plus A minus B. Third entry will be C minus A plus A minus B plus B minus C. Second row and third column will remain the same. So this will be B minus C, C minus A minus B. Here it will be C minus A minus B, B minus C. There won't be any change. If you look at it, plus A minus then plus B minus B, plus C minus C. All terms will get cancelled. Similarly here also, plus A minus A, plus C minus C, plus B minus B. Here, plus A minus A, plus B minus B, plus C minus C. All terms got cancelled. So I will be left with 0, 0, 0, B minus C, C minus A minus B, then C minus A minus B, B minus C. Now, since all the entries in the first row are all 0, the value of the determinant also will be 0. So you have to conclude here 0. What is the reason you are going to write? Since all the entries in R1 are 0. That's why the value is 0. You need to conclude your answer. The value of this determinant is equal to 0. That will be your final answer. So it's very easy question. Even you can think in this manner. You can write your C1 as C1 plus C2 plus C3. In that case, what will happen? All the entries in the first column will become 0. So the value of the determinant is going to be 0. That is the other way of looking at the same sum. Okay. Now, we will move on to question number 5. Here, using the properties of the determinant, you need to prove that determinant B plus C, C plus A plus B, Q plus R plus P, P plus Q, Y plus Z, Z plus X plus Y is equal to 2 times the determinant A, B, C, P, Q, R, X, Y, Z. It's a very important question. This question was asked in 2010 and in 2012 board examination. Now, let's do this sum. Solution. LHS. B plus C, C plus A plus B, Q plus R plus P, P plus Q, Y plus Z, Z plus X plus Y. So what I am going to do? I am going to write C1 as C1 plus C2 plus C3. That will give me, see here, B plus B, 2B, 2C, 2A. So 2 times A plus B plus C. Then here 2Q, P plus P, 2P, R plus R, 2R. So 2 times P plus Q plus R. Same way the third row will be, here if you see, you will have 2 times X plus Y plus Z. Now, second column will remain the same. There won't be any change. And third column also will B will remain the same. A plus B, P plus Q, X plus Y. Now, I can take out 2 from C1. So, taking out 2 from C1, I will get LHS equal to 2 into determinant A plus B plus C, P plus Q plus R, X plus Y plus Z, then C plus A, R plus P, Z plus X. Then A plus B, P plus Q, X plus Y. Okay, we take the C2 as C2 minus C1 and C3 as C3 minus C1. That will give me, writing C2 as C2 minus C1 and C3 as C3 minus C1 will give me LHS is equal to 2 times determinant A plus B plus C, P plus Q plus R, X plus Y plus Z. Now, C plus A minus of this. So, C plus A will get cancelled with minus A, minus A. I will be left with only minus B. Same way here, R plus P will get cancelled with minus R and minus P, left with minus Q. Here also, Z and X will get cancelled with minus X and minus Z, left with minus Y. Okay, now same way if I do this, A plus B minus of this will give me minus C, P plus Q minus of this will give me minus R, and X plus Y minus of this will give me minus Z. This is what I am getting. Okay, now what I am going to do is, I am going to write C1 as C1 plus C2 plus C3. Then what will happen? Plus B minus B plus C minus will get cancelled. I will be left with only A, P and X. Okay. So what I am going to do is C1, I am going to write it as C1 plus C2 plus C3. LHS will be 2 into determinant plus B minus B and plus C minus C will get cancelled. I will be left with only A. I will have A, P and X minus B minus Q minus Y minus C minus R minus Z. This is what I am having. Now I can take out minus from C2 and 1 minus from C3. So, taking out minus, I will write minus 1 from C2 and the negative sign minus 1 from C3, I get LHS equal to 2 times minus 1 the whole square, left with A, P, X, B, Q, Y, C, R, Z. Minus 1 the whole square is 1. So, this is nothing but 2 into determinant A, B, C, P, Q, R, X, Y, Z. A, B, C, P, Q, R, X is 2 times, which is equal to RHS. Therefore, this determinant is equal to 2 times ABC, determinant ABC, PQR, XYZ. Hence proved. Then you need to rewrite the answer. You have to write this entire statement. That will be the final answer.